All problems from MIT Integration B 2016, and that's also live without preparation. And I just hope that it will go well. And I'm also thinking of collaborating with you in the solution, hoping that you would help me get the ideas whenever I'm stuck, right? And I'm also trying to interact with you as much as I can. Okay. So I think I can check the chats from here, right? Oh yeah, here's my live video, right? Okay. So I will also check the chats, and I also have it on my phone. I can check it from there as well. So I will also check the chats. Let me just type something on the chat. Hi. Okay. So yeah. Hope it goes well. So let's start solving the problems. Okay. Whew. So the first one is integral of tan x dx. We also have the answers over here, right? Okay. Integral of tan x dx. One number. Integral of tan x dx. Now, how do you think we can solve this problem? This is a pretty easy problem. First of all, let's break tan x as sin x divided by cos x times dx, right? Now if we let cos x as y, we know that dy by dx for cos x is just sin x, right? So we get dy as sin x dx. So we see that sin x dx, this person is just dy, right? So that's just dy, and cos x is y. So this is ln y plus c. Don't forget the constant. And y is cos x, so it's ln of cos x plus c, which is the answer. So let's check our answer if it's right or wrong. Yeah. Oh wait, did I just cancel that? Okay, let me create. Let me just remove these other tabs, and then I will. Yeah. Again, search for the MIT Integration B, and it's over here. I can just go to the solutions of 2016 answers. Okay, so yeah, it's log of cos x, which is the right answer. Now next one, -4 to 4 modulus of x cube minus x dx. Okay, two number. Integral from -4 to 4 modulus of x cube minus x dx. Okay, now how do you think we can solve this problem, right? Now, first of all, I think we can just try to see like this, how the modulus of x cube minus x graph might look like, right? Okay, so let's just try to plot it first. This is x times x square minus 1, x times x plus 1, x minus 1, right? So that means its graph will be, okay, let's say this is 1, this is 0, this is -1. So beyond 1, this will definitely be positive, right? Because all of the terms are positive. So the graph comes like this. And at 0, this is 0. And between 0 and 1, this is negative, right? Again, between 0 and -1, in this range, both of these quantities will be negative. So, and this will be positive. So overall, this will be positive. And beyond -1, all three will be negative. So that will go negative. So this is our graph, right? And now in the modulus, in the graph of the modulus, over here. So how will the graph of the modulus look like is, so from -4 to 4. In this range, we need to introduce a negative sign. Sorry, not -4 to -1. -4 to -1, we need to introduce a negative sign, right? Since the graph initially is positive. So we will write, in this range, we will just write x minus x cube. And from -1 to 0, it's already positive, so no need to do anything. And from 0 to 1, we will introduce negative sign. We are introducing a negative sign to this function, right? Because we have to make it positive. So if we introduce negative sign, this will be x minus x cube. And from 1 to infinity, 1 to 4, it's already positive, so no need to do anything. So x cube minus x. I hope you see that we are just introducing a negative sign over here, so as to make our integrand positive, right? So now we need to integrate this thing. Now notice that if we make a substitution over here, if we make a substitution that, let's say, y is equals to minus x, this will go from 4 to 1 minus x plus x cube, right? And then again du will be minus du, right? This is dx initially. Now if we make just if I'm just trying to change x to minus x itself, so this will be minus dx, right? Over here, if I make change x to minus dx, this will go from 1 to 0 minus x cube plus x. Here will be minus dx, right? And over here I will not change these things. And notice that since I have not written anything, that's just dx. Yeah. Okay. Hi Tamal. Like, nice to see you after a long time. Okay. Now we are solving this integral. So over here, what I have just done is I have made a u substitution. I changed x to minus x, so as to make the limits positive. So now this is integral from 4 to 1 of x minus x cube, x minus x cube, and then dx, plus integral from 1 to 0 of, this is also x minus x cube dx, right? Okay, wait, this is not, this is x cube minus x, if you, sorry, x cube minus x. Okay, and then next is 0 to 1 x minus x cube plus 0 to 1 x minus x cube dx, plus, and then 1 to 4 x cube minus x dx. Now notice that if we yes, after a long time, yeah. Now if we just reverse the limits of integration, this will we can make it go from 1 to 4 with a negative sign introduced over here, right? So we can write this as 1 to 4 x cube minus x dx, plus 0 to 1 x minus x cube dx, plus 0 to 1 x minus x cube dx, plus 1 to 4 x cube minus x dx. Now this can be written as 2 times integral from 1 to 4 of x cube minus x dx, plus 2 times integral from 0 to 1 of x minus x cube dx. This is actually obvious from the graph itself, since these two areas will be equal, and also this one will be equal to this one. So that's the same thing we have got from algebraic manipulation, right? So the sum of these two areas, this area being made as positive area, right? So sum of these two areas and then the twice of that answer. So that's what we are going to find over here. So 2 times, now this will be x to the power 4 by 4 minus x square by 2, going from 1 to 4, plus 2 times x square by 2 minus x to the power 4 by 4, going from 0 to 1, right? And that is, so 2 times okay, I think this was supposed to be just like this. Okay. These brackets were a bit messed up. Even functions, so 2 times, yes, exactly Muhammad. So now if I evaluate this, this will be 4 to the power 4, which is 4 to the power 4 divided by 4, which is 4 cube, and that is 64 minus 8 minus, this is 1 by 4 minus half, plus, I'll just take 2 common over here. The 2 is over here, for this 2 is over here. Now 1 by 2 minus 1 by 4, 8 0, there is just 0. So this is now 64 minus 8 minus 1 by 4 plus half, which is also over here, plus half minus 1 by 4. So that is 2 times 64 minus 8 plus 1 minus half, which is 2 times 64 minus 8, that's 76, right? So what's the answer, guys? Can you give me the answer? So 64 minus 8 is 76, and plus half is 76 whole half, right? 76 and half. So that is 152 plus 1, right, which is 153. Is that the answer, guys? 153. Let's see. Oh, it's 113. I think we messed up somewhere. So we wanted to find 76. What is the double of 76? I think I missed it. It's 152, right? Guys, so 64. Oh, yes. 64 minus 8 is 56. I'm sorry. And that is 112 plus, which is 113. Thank you, Muhammad. So, yeah. So, yeah, it's 113. And the answer matches. Now, let's go to the next question. Which is, okay, now suggest an idea for this one. Integral from 1 to e of log of root x dx. It feels like, first of all, I should make a u substitution, right? 1 to e log of root x dx. So what do you think, Muhammad? Like, I feel that I will make a u substitution as u is equals to root x, right? And then u square is equals to x. So this will be 2u du is equals to dx, right? Now after here, if I make this substitution, I will get, now since u is root x, it will go from 1 to root of e, right? And then this will be log of u, dx will just be 2u du, okay? I think now it's doable, right? 1 to root e, u log u. Yeah, this can work, yeah, exactly. Now, since this is u log u, I can make this as the u and this as our b. So log u will be log u. The integral of u will be u square by 2 minus the integral of derivative of log u is 1 by u, and integral of u is u square by 2. Yeah, now it seems like it's working. This is from 1 to root e to u square by 2 log u square by 2 log u minus, now this is just u by 2, so that's u square by 4, and all of this is from 1 to root of e. So 2 times root of e squared is e by 2 log of root of e minus this is e by 4 at 1, that's just 0, plus this is 1 by 4. So this gives us okay, e log root e minus e by 2 plus 1 by 2. So again, log of root e is just 1 by 2. So e by 2 minus e by 2 plus 1 by 2. E by 2 cancel out, gives us half. What a nice answer, right? Let's check if it's half or not. Yeah, it's half. So that successfully works out. Let's go to the next question. Wow, next question is awesome. e to the power x plus e to the power minus x plus x, e to the power x plus e to the power minus x. Looks good. Phone number. Integral of e to the power x plus e to the power minus x plus x minus. The minus is in exponent or no, it's not an exponent, I guess. It's not an exponent. Okay. Plus e to the power x plus e to the power minus x. Okay, so let us think how to solve this problem, right? Okay, so I feel like I should write this as, Okay, e to the power x plus e to the power minus x times e to the power x. Let me make this breakdown. I don't know if that will be helpful or not. Let me know if you have any ideas. Okay, I'll just think what is possible. Let's say if I make this substitution, e to the power x plus e to the power minus x. Okay, guys, wait. I think I observed something. Okay, if I take this as common, I get e to the power x minus e to the power minus x, right? Now, if I let this as u, my du will just be e to the power x plus e to the power minus x times derivative of the exponent now, e to the power x minus e to the power minus x dx. So this is exactly this du, and that's awesome. So I get du, which is just u plus c, and so u is e to the power x plus e to the power minus x. That is awesome, man. Did you like it, Mohammed? I found this problem very beautiful. Yeah, exactly, Mohammed. Exactly, you are right. Just take that as u, and then take that common and let that be u. You will get the du as the thing that's over here. So let's see the answer. Yeah, that's the answer. Let's go to the next problem. Log of x. I think this is a pretty standard problem. This 5 number is pretty standard. Log of x by x log x dx. Let's do that. 5 number. Integral of log of x by x log x dx. This is a pretty standard problem, right? I think everyone knows how to solve this. Just take the numerator as u. If you take numerator log of x as u, the rest will just be du, and it's too easy. So du will just be 1 by log x times 1 by x dx, right? First of all, we take derivative of this log over here, which is 1 by this entire thing. Again, the derivative of this log, which is 1 by x. Derivative of x is just 1. So yeah. And since we know that this person is all du, so now we can say that this is u times du, which is u square by 2 plus c. So this is log of x square by 2 plus c, and that's the answer. This is a pretty easy problem actually. Yeah, log of x square by 2. Now let's go to the next one. Integral from 0 to pi by 3 of dx by 1 plus tan square x. Okay. 6 number. Integral from 0 to pi by 3 of dx by 1 plus tan square x. This is the problem, right? This is the problem. Yeah. So guys, what's your suggestion on this one? I think this is a standard formula, right? Sec square theta minus tan square theta is just x. So yeah, of course, tan square x plus 1 will just be... Oh, this is pretty easy. This is again an easy problem. So now we know that that's just sec square x. So this will just be cos square x dx. And cos square x will just be 1 plus cos 2x by 2 dx. Now this is just x by 2 plus sine 2x by 4. Going from 0 to pi by 3. At pi by 3 it's pi by 6. Plus sine of 2 pi by 3. Sine of 2 pi by 3, which is sine of 120, which is just root 3 by 2, right? Root 3 by 2, so root 3 by 8, minus 0, which is pi by 6 plus root 3 by 8. Okay, let's see that if it's correct or not. Pi by 6 plus root 3 by 8. Yeah, exactly. Now next one. Yeah, minus 27 to... Oh, this looks pretty hard, but this is pretty easy actually. Minus 27 to 27 arc sine of x to the power 1 by 3 dx. Okay. The dikta hai wo hota nahi. This is in Hindi saying, which means that whatever looks to be hard is actually easy. Minus 27 to 27 sine inverse x to the power 1 by 3 by they make it look so complicated. X sin of x to the power 1 by 3 by 3. Okay. Now how we can solve this is, this one is actually an odd function. So if you take f of, if you say this is f of x, if you take f of minus x, that will just be sine inverse of minus x to the power 1 by 3 dx. And since if the exponent here, this is the cube root, right? And cube root of minus x will just be minus of cube root of x, right? Because minus 1 is same as writing minus 1 3 times. Yeah. And so minus 1 can be taken out. So yeah, if we use that, this will just be sine inverse of minus x to the power 1 by 3 dx. Again, since sine inverse is odd function, minus comes out. So yeah, we see that overall it's an odd function. So now for odd function, we know that graph is, yeah, odd function. Yeah, we know that for odd function, graph is symmetric about origin, right? Graph is something like this. Yeah, like basically the idea is the area, these two areas will just be equal and opposite. So due to the opposite sign, they cancel out and the area is 0. So this integral is just 0. Okay, so the integral is just 0. I'll go to the next one. This was a good one. Now the next one is 8 number. Integral from 50 to 100 log 2x dx. Okay. 8 number. Integral from 50 to 100 g of log 2x dx. This is it, right? Integral from 50 to 100 g of log 2x dx. Yeah. Okay. So definitely, because this is the complicated function, we will first make a use of substitution that u is log 2 of x, so as to simplify it, right? If we do that, this is just 2 to the power u is x. Now 2 to the power u log 2 du. Derivative should also have a log of that number, right? If it's not e to the power x, if it's something else. This is dx. So we get this is now log 2 of 50. Do I even need to do that? Because that seems to complicate it a lot. I think I can just go over analyzing the stops over here instead of doing this thing. Since here's a g function, I can just go and analyze. Yeah, break the integration and yeah, I think let me go with what Mohammed's saying. Let me just pick it. Okay, now we know that let's first analyze the powers of 2, 4, 8, 16, 32, 64, 128, right? So in between, okay, so over here there's 1, 2, 3, 4, 5, 6, 7. Okay, yeah. Now in between 50 to 64, so the g of log 2 will give us 5, right? Because 2 to the power 5 is 32, and if it's less than 64, it will be somewhere around 5.5 or 5 point something like that. If I take g of that, it will again be 5, right? So yeah, so between 50 to 64 we will just get 5. In between 64 to 100 we will just get 6, right? Because if number is greater than 64 and less than 128, the log will somewhere between 6 and 7, and if you take g of that, we will just get 6. So yeah, this is a good approach, and thanks to Muhammad. Now this is 5 times, it will be 14, plus 6 times, this will be 36. Yeah, I guess so. So this 70 plus 216, right? Yeah, and that's 286. So let's check the answer if it's 286 or not. Let's check the answer if it's 286 or not. Yeah, it's 286. Okay, let's go to the next one, which is e to the power x. Oh, this one is too easy. E to the power x cos x minus e to the power x sin x. Just you can dismail the product rule over there, right? Again, 9 number. Integral of e to the power x cos x minus e to the power x sin x dx. Like, can you tell me the answer directly without even solving it, guys? I guess you can, right? This isn't too hard. It's just e to the power x cos x, right? Because if we differentiate this, okay, if we just go with the product rule, first of all, let this be u, let this be b. Derivative of u is e to the power x cos x, plus now derivative of b is minus sin x. So you get the answer, right? This is too easy. You can just analyze it. And if you want to do it rigorously, you can also use the integration by parts on the first function. That will cancel second one, and we get the answer. Okay, this is e to the power x cos x, right? Smell the product rule. Nice line. Yeah, thanks for that. So this is e to the power x cos x. Okay, next one is x cube e to the power minus x squared dx. It to the sorry, what was it? What was the question? 10 e to x cube e to the power minus x squared dx. Okay, 0 to infinity x cube e to the power minus x squared dx. So let's try to solve this problem. So I think what we can do over here is we can break the x cube as x square and then x dx. The reason for doing that is to make a u substitution, right? So if we break it like this, now if we make u is equals to x square, we get du as 2x dx, right? So we get du by 2 as x dx. Yeah. Now if we make the substitution, now the limits will go from 0 square is just 0, infinity square is just infinity. Now that's u e to the power minus u, and then x dx is just du by 2. Now it's a pretty easy integral. Now it has simplified a lot. Now you can just use the integration by parts, right? So if we use the integration by parts, now let me say this as our u, this as our b. So this will be u, integral of that will be e to the power minus u by minus 1 from 0 to infinity minus integral of derivative of u is just 1, integral of e to the power minus u is e to the power minus u by minus 1, and this goes from 0 to infinity. Don't forget du over here, right? So this is 1 by 2. Now this is just minus u e to the power minus u, right? Minus, now the minus sign, minus 1 is over here. Again, if we integrate this, another minus 1 will come, so they will just cancel out. This goes from 0 to infinity. So 1 by 2. Now there's the indeterminate thing over here. Notice that if I evaluate this at infinity, u will go to infinity, but e to the power minus u will go to 0, right? So there's infinity times 0. So if there's an indeterminate like terms, we need to use limits. So let's try to find the limit. So limit u goes to infinity of u e to the power minus u. Now if you know the orders of, I mean, what do you call that? Orders of, I don't know, orders of infinity, something like that. Yeah, anyways, like if you just, there's an idea that since e to the power u grows way faster than u, so at infinity e to the power u will be much bigger, due to which this goes to 0, right? So you can also use that idea, or you can also use L'Hopital's rule. If you use L'Hopital's rule, since both of these expressions are going to infinity at infinity by infinity form, just differentiate this, which will give you 1 divided by e to the power u. Now you can substitute the limits. So it's 1 by infinity, so 1 by e to the power infinity, which is 1 by infinity, which is 0. So yeah, you can also do it from L'Hopital's rule as well. So anyways, we know that this goes to 0, right? So this is minus 0, and this will also be 0 because e to the power minus infinity is 0, and then again minus at 0, this will be 0, and this will be minus 1. So it's 1 by 2 times 1, which is half. That's the answer, right, guys? Did you get the same answer? I think you got the same answer, right? It's, wait, what's the answer? It's half. Is it? So let us check. Yeah, it's half. Let's go to the next question. Whoa. Guys, I can again smell something. I think it's okay. Okay, let me not see the answer directly actually. Okay, wait. Let us first. 2 e to the power x square times x plus 1 cos x, integral of 2 e to the power x square x plus 1 cos x, 2 e to the power x square x, this is so long here, plus 1 cos x, plus 1 cos x. I need to improve my handwriting as well. Minus e to the power x square plus x, minus e to the power x square plus x sin x dx, sin x dx. Okay. First of all, notice that for this one, if you just take this expression, okay, yeah, if you take the expression, let's say e to the power x square plus x times cos x, yeah, you will notice that if you again differentiate this, now how did I know this expression? Because basically if this is u, its derivative du is over here, and if this is b, its derivative dv is over here along with the minus sign. So it was pretty obvious, right? So now if we differentiate this, first of all we will have du by dx, which is over here e to the power x squared dot 2x plus 1, and v will be as it is, cos x, right? And then plus, now u will be as it is, and its derivative is minus sin x. So you can see that it's pretty obvious the main integrand from which this has been derived. So that's the answer. If you want to do it more rigorously, use integration by parts. That will also give you the answer. Let's see. So e to the power x square plus x times cos x plus c. That should be the answer. Yeah, and that's the answer. Let's go to the next one. Let's go to the 2L number. Oh wow, I think this one is a good one. So guys, what do you think about 2L number? 1 plus x to the power half plus x to the power 1/3, 1 plus x to the power minus half plus x to the power minus 1. This one is a good problem, I guess. What's your idea on this? What's your take on this? Integral of 1 plus x half plus x 1/3, 1 plus x minus half plus x minus 1/3. Do you just feel that I should multiply it and then solve it, or what do you think? Should I just multiply it? Is there a good way? Is there a good way? Is there a good way? Shall I just multiply? I think that's an easier way, right? Okay, let me just multiply, guys, because I cannot really see anything else that I can do with this. Definitely I can make a substitution, like your u is equals to x to the power 1/6. That can help to simplify things, but again, it's not a lot useful though. Here will just be x squared x cubed and x to the power 6. I don't think that will do a great help to us anyways, right? Okay, let me just multiply, because I got no suggestions. Let me just do whatever I think is good. So if I do that, I will get 1 plus x to the power minus half plus x to the power minus 1/3 plus x to the power half plus x to the power 0 plus x to the power, this is 1/6 plus x to the power 1/3 plus x to the power, this is getting pretty messy though. Let me just do it anyway. Plus x to the power, now that's 1/6 plus x to the power 0. Oh wait, 1 x to the power minus x to the power minus 3rd plus x, this is wrong, plus this should be minus 1/6 and this should be 0. Okay, now that's fine. Yeah, Okay, now after that we have 3 plus we have x to the power minus half plus x to the power minus 1/3 plus we have x to the plus we also have x to the power minus 1/6 x to the power half x to the power 1/3 x to the power 1/6, right? So now let's just integrate it. This will be 3x x to the power half by half plus x to the power 1/3 by 1/3 plus over this will be 2/3 not 1/3 2/3 by 2/3, right? This is x to the power 5/6 by 5/6 plus this will be x to the power 3/2 by 3/2 x to the power 4/3 by 4/3 plus x to the power 7/6 by 7/6. So this is the answer. There's a bit messy answer though, but yeah, this works anyway. Now let's see the good answer and try to derive the good answer. What's the good answer over here? Oh, they have also done the same thing? Can't believe. Okay, so 3x is there and 2 by 3 x to the power 3 by 2. That's what we have, right? And then 3 by 4 x to the power 3 by 4 x to the power 4 by 3 6 by 7 x to the power 7 by 6. Yeah, we also have that. 3x is there, 6 by 5 x to the power 5 by 6. We also have that. 3 by 2 x to the power, we also have that. 2x. We have the same answer, man. I didn't know that this answer would be too messy because ambient integration be usually supposed to be beautiful, right? Guys, like, was your approach the same or was it different? Did you think of the same way or did you have anything else in mind that could work? Next problem is sine of sine x, cos of sine x, cos x dx. 13 number. Integral of sine x, cos of sine x, cos x dx. Cos of sine x, cos x dx. Okay, now how do I solve this? First of all, I do know that if I make substitution of sine x as u, cos x dx will just be du. So let me do that. U is equals to sine x, du is cos x dx. So this is sine u, cos u, du. Again, if I make b as sine u, I will get cos u du as dv. So this is b dv. Now this is just b square by 2 plus c. And we know that b is just sine u. So this is sine u square by 2 plus c. Again, u is just sine x. So this is sine of x square by 2 plus c. And that is the answer. So this is sine of x square by 2 plus c. Yeah, that's the answer. Let's go to 14 number. Cos plus sine by x square plus sine minus cos by x dx. Cos plus sine by x square plus sine minus cos by x dx. Where have you guys gone? You aren't responding. Cos plus sine by x square, sine minus cos by x. Cos x plus sine x by x square. Cos x plus sine x by x square. Plus sine x minus cos x, sine x minus cos x by x dx. Whoever guys are there, can you please respond what your idea is so that it will be interactive and fun, right? Now how do I do this? I think that this is also a similar problem, just using product rule, right? Now this time I think this is a combination of cos x sin x and 1 by x, maybe minus 1 by x. Okay, let me check if this works or not. So if I differentiate this, first of all, this will be as it is, cos x plus sin x, right? Its derivative will be 1 by x square. plus. Now if I differentiate this, minus sine x plus cos x, right? And it will be as it is. So yeah, it works, right? So now it works. Cos x plus sine x by x square. Now this is just plus of sine x minus cos x by x. So guys, it's pretty easy to guess, right? First of all, what you can do is try to take this expression and then integral of the other expression. So I did that. This expression as it is in the integral of 1 by x square. So yeah, because that's how it works, right? Later on we get this expression and derivative of this one. So yeah, try to make that observation. That's pretty helpful actually. It might not be helpful in the real life integrals, because real life integrals are too complicated and you have to like go rigorously, right? But in the competitions integral, like it's almost the case that the answers will be beautiful and nice. There will be tricks involved. So yeah, such observations might be helpful. Yeah, thank you, Muhammad, for complimenting. And I think I think that's the answer that they have given. So yeah, negative of the sine x plus cos x by x. Let's go to the next one. The next one is x cube times square root of x square plus 1 dx. So in 15 number, integral of x cube times square root of x square plus 1 dx. So let us see how we can solve this one. So what do you think? Do you think that u substitution might help? Do you think that u substitution might help? I think that it helps. I can just break x cube as x square and x. Now if I make a substitution that u is x square plus 1, I will get du as 2x dx. So du by 2 is equals to x dx. Now x square is just u minus 1, right? And then this is the square root of u, that's du by 2. So that's pretty helpful now. Now this is just 1 by 2 integral of u to the power 3 by 2 minus u to the power 1 by 2 du, which is easily integrable. 1 by 2 u to the power 5 by 2 by 5 by 2 minus u to the power 3 by 2 by 3 by 2 plus c. And we know that u is actually x square plus 1 to the power 5 by 2 by 5. 2 cancels out. X square plus 1 to the power 3 by 2 by 3 plus c, and that's the answer. This was easy, right? If you just know that u substitution, everything else is pretty easy. X square plus 1 to the answer is slightly different. So I think we're going to take LCM to get that answer. Let's take the LCM. If you take the LCM, this will be 15 and then 3x square plus 1 to the power 5 by 2 minus 5x square plus 1 to the power 3 by 2 plus c. Now if you take x square plus 1 to the power 3 by 2 common, this will just be 3x square plus 3 minus 5 by 15, and that is x square plus 1 to the power 3 by 2, 3x square minus 2 by 15. I guess that's the answer given there. X square plus 1 to the power 3 by 2. Yeah, 3x square minus 2 by 15. Yeah, that's the answer. So yeah, sometimes the answer can be in different form. But yeah, it's always possible that you can take your answer to the other form, which is also correct answer. Because in maths, all the correct answers should be same, right? Like that's obvious. Let's go to the next one, 16 number. We are almost to the end. There are just a few more questions left, right? Today it was pretty fast, yeah. This in my other live videos, it was a bit slow, but today, since you guys interacted so much, it was fun and fast. Let's go to the next one. X by x to the power 4 plus x square plus 1. 16 number. Integral of. So what do you think for this one, Muhammad? How will you approach this problem? Yeah, how will you approach your idea? I think, yeah, exactly. I will also do the same thing. Let's say x square is t, then 2x dx will be dt, right? So over here, this will just be dt by 2 now, right? Because there's x dx. Now this is t square plus t plus 1. And now we can just do those high school maths stuff. Completing the square, right? Now if we complete the square, we will have t square plus, wait, how did I get this? Okay, t square plus 2t half plus half square minus half square plus 1. Now the approach is to complete the square with the first two terms, t square as it is, and 2 times half is just t, and then since square needs 2ab, now this should be b square, and this b square was introduced by ourselves, subtract b square and then plus 1 as it is. So we get half of dt by, this is t plus half square, this is minus 1 by 4 plus 1, so that's 1 minus 1 by 4, that's 3 by 4, so that's root 3 by 2 square. Now we know that integral of dx by x square plus a square, this is just 1 by a tan inverse x by a, right? So yeah, this is 1 by 2, 1 by a tan inverse x by a, yeah, and plus c. So 2 cancels out, it's 1 by root 3 tan inverse 2t plus 1 by root 3 plus c. We know that t is just, and we know that t is just x square, right? So it's 1 by root 3 tan inverse 2x square plus 1 by root 3 plus c. That's the answer. I think you get it, right? Yeah. Let's go to the next one. Let's check the answer. 1 by root 3 tan inverse 2x square plus 1 by root 3 plus c. Yeah, 1 by root 3 tan inverse 2x square plus 1 by root 3 plus c. The next one. Let's go to the next one. The next problem is e to the power.
Sorry, you can stay. Do you have the room booked?
No, I don't have the room.
Okay, you're good. We're just meeting in 10 minutes, but you're welcome to stay till then.
Oh, okay. Yeah, I was recording a video, but yeah, I think I will cancel.
Oh, sorry about that.
It's fine.
Yeah, we have the room.
Yeah, I'm sorry.
You're good.
Okay, I'll continue.